Hello, everyone. Welcome back to Kids Python Challenge. Okay, let's enjoy today's turtle drawing. Let's continue. Okay, so where were we last time? So we drew a very, very colorful spiral using, say, half p circles function. And p circle was made from polygon function, right? Remember how to do that? So there was no homework. So let's quickly check the code. So open E3, connect, and then run the first cell, pip install ColabTurtle, and then going down. Let's see. So today's content is a bit advanced. Maybe you need some knowledge about mathematics. So don't worry if it's not, if you don't understand it fully. So, okay, let's see. Let's see the last box. So we drew we used half circles, and half circle used nothing else. So let's quickly erase the result and rerun the box. Okay, we start from red, changing colors frequently, and drawing spirals, which is composed of half circles. And each half circle is composed of lots of line segments. Okay, so let's see. Let's go down. And again, oh, okay, let's open several boxes here. Copy polygon and p-circle, and how to start the drawing. Okay, so let's copy this part. Two cells up, and definition of polygon. Okay, oops, doesn't work very well. And I don't know why it doesn't work. So, okay, anyway, let's copy this cell. Copy cell and going all the way down and paste it here. Okay, so we have definition of polygon here, and then definition of p-circle here. Okay, so let's see what we're going to do today. Drawing a more accurate circle. We know that p-circle is almost a circle. So let us see how we can overlay p-circles better. Okay, so let's see. Anyway, let's draw p-circle. So p-circle is believed to have a center at xy and have r's. So let's run it. Okay, we don't need colors today. So let's draw here. I see. We can't, it seems it's a bit strange. Okay, so let's fix these sides to be sorry. So let's delete this part. Okay, and then okay, we don't need the result. Okay, so the point is we want to start from the same position and draw circles with increasing number of n sides. Okay, let's do that. So we start from r is like 100, and then go to say t go to say 200 and 200, and then starting We don't need colors. So we start with pen color blue, and then P circle in increasingly N. Okay. So the second one is we use N instead of I. Starting from 3 up to say 18. And the last argument, the fourth argument should be N. Okay, with the same R. And we don't need this actually. Okay, let's run it. Okay, maybe I'll stop this. And what's wrong with this? Maybe we want the coordinate to be 300, y coordinate to be 300, and pi, pen size should be back to 1. We want. Okay, let's run it again so that we can see everything. So 3, 4, 5. We start from triangle and go all the way up to polygon 18. So what do we observe? In the last half, it is good, but in the beginning, the position is a bit strange. Triangle, square, pentagon, hexagon, they are in strange position. Let's see why is that, why that happens. So more precisely, we should write, we want this kind of thing, okay? So if we want this kind, what can we do? The point is that, okay, let's see. So from center and go, now the code is going pen up and going R, and start from there, writing like triangle. So we should actually start from, instead of starting from here, we should start from here to write triangle, for example. So what is this angle? This should be 30, okay? So go left by 30, go right by 30 degrees, head north, and then start. In case of square, we should go 45 degrees and start north. So it's like going by 180 over n angles, and this is theta is like 180 over n, and they go straight. So let's try that as a variation. Instead of going p circle, so let's change p circle to p circle 1, 2, like go, instead of going to straight to x, maybe we can change, yeah, this, okay, this is equivalent to t left 90, t right 90. The current code is the same as going righty t forward by r, and then starting from there. Okay, instead of, this is equivalent to this. Okay, so let's check before going on. This is what we are doing. And maybe we can do it up to 8. Okay, let's see. Does this give the same position? Ah, I see. I see. Okay. Maybe to do that, we need to go back to the original position to up and going back to x and y. This will give the same as before. Okay, let's write it. No. What's wrong with it? Let's see. The polygon is pen down, starting from that position and writing this. So let's see. Pen up. I see what's wrong. I forgot to turn back to left by 90 before starting to draw. Okay, let's see. Does this give the same? Okay, yeah, right. So this is the same, but as I explained, because it doesn't overlay very well. So to do that, what we need is additionally going plus theta degrees more. So let's do that. Let's check that this works. So instead of going by right 90, we could write 90 plus 180 over n. Okay. And then maybe we can write the same thing here. Okay, let's check that. And if this gives a better result. Oh, okay. Almost good. Only the triangle is different. What's wrong? In case of triangle, okay. I now I find what's wrong. So I forgot to write t go to center in the beginning of B circle. Okay, so maybe I need this. So okay, go to XY and then okay, let's run it. 4, 3, 2. Sorry, this is 9 and this is 10, 8. Or okay, let's run it to check that everything is okay. So this seems fine. Okay, or even we can change this to 18. Now everything is in the right position. Good. Okay, good. So this was good. Or alternatively, maybe we can use, instead of using turning left, we can use head, what was it on the thing? Set heading. Set H, say minus 90. To do the same thing instead of writing. So this will always head north. Okay, this is equivalent. So this is relative way, and this is kind of absolute way to head north. Okay, so what's next? So maybe we can do it a little more accurate by using, instead of 3.14, we can use mathematical value of pi. Okay, so for that, maybe we can use, let's see. So where is 3.14 here? Okay, so maybe we can use, for example, here, or before that. This is the way to import math. And instead of using 3.14, we can use, where is it? Okay, instead of 3.14, we can use math pi. Okay, this will make a little more better. So better Let's change it back to 10. Okay. So this is way to use the more accurate value of pi instead of 3.14, which is an approximation. Or even yet another approach. Maybe we can, if you're good at mathematics, this is equivalent to starting here, okay, going left by cosine theta, and then going down by sine theta. Okay, this is also the same. Maybe if you were interested in mathematics, you can check that. Instead of going theta, angle theta, and going right r, we can go, sorry, r cosine theta to east and going south by r sine theta. If you're interested, you can check, program that and do that. Okay, this is the same as, instead of this sequence, we can write as, okay, so yeah, t, that's right, t right by 90, okay, sorry, and then forward by r times math dot cos n over 180 over n, and then maybe go set head north, and then forward minus r times, we're going backward by writing negative r times math sine 180 by over n, and continue this. So let's check that this gives the same result. This doesn't give the same result. What's wrong? T right 90, t right 90, r math cosine. Sorry. Now I noticed that for using math cosine, we need to write it in radian. So it should be, instead of 180, we should write math pi. Okay, same here. Instead of writing math 180 by degrees, we should write in radian. So we should change this to pi. Okay, let's try this. Okay, so now we can see it gives the same result as before. So yeah, this is equivalent to writing this way. Okay, so lastly, I'd like to point out that this is correct, because as you know, if you're familiar with mathematics, triangular mathematics, this one, the ratio of theta by sine theta goes to 1 as theta goes to 0. So meaning that this is equivalent to s goes to a large number. So this is very good approximation. This is what I wanted to add as a last thing to write. As we increase n, we can do very well approximation of drawing a circle. Okay, that's all for today. Thank you very much. So be sure to come back. Bye-bye.